mathematical, that is in terms of data sets, it is given to you. You don't have the continuous function s equals to function of t. That continuous function you don't have, such that you may be able to calculate easily or mathematically ds by dt or d2 or d2s by dt2. These type of things, mathematical calculation is not easily you can able to calculate. Okay, so with the help of numerical techniques, how we will calculate these terms? Initial velocity means ds by dt. ds by dt is velocity v, and that is initial means if it is initial, if initial, then t equals to 0. If you will consider t equals to 0 initial, then t equals to 0 is not first point. You just see t equals to 0 is not first point. Okay, then what you have to do, as usual, with the help of Newton forward interpolation, you just construct a polynomial. That polynomial s will be function of t. In that polynomial you have to put t equals to 0. That is the laborious process. You will not able to use that very easy formula. This type of easy formula you cannot able to use. This formula simply you can able to use if this formula means asking point is coincide along with the starting point or last point. Then you may able to use this type of formula. Otherwise, as usual, lengthy process you have to use, because t equals to 0 is not coincide along with this point. Now, if it will be asked to you, find out the velocity and acceleration at 1.5. If you will consider velocity at 1.5, that 1.5 is the first point, and you know the expression of finding the derivative at first point. Is it clear?
Yes, sir.
Okay, so find the velocity and acceleration means at that point first derivative, at that point second derivative. Similarly, at 2.0, suppose at 2.0 it is asking to you find out the velocity and acceleration means first derivative and second derivative at this point. Means after constructing the difference table, associate to this element which will be the upper diagonal, that elements you have to pick up and you have to use same formula of upper diagonal what is you have derived. Okay, and for these 2 points 3.5 and 4.0, velocity and acceleration calculation, you will use these two formula. Okay, now come to this point. Just see this difference table, that is we have done before also. Somebody you have done before also. So that t data I am writing in first column, associate or dependent s data I am writing in the second column. That is the y data and t value is the x data. Looks like that. In that way you just think. Okay, first difference subtract, in this way subtract this from here, you will get this. In that way, first difference column, this is the second difference column, this is the third difference column. Fourth difference 0, fifth difference 0. Okay, so okay, first of all, to calculate derivative at t equals to 0. T equals to 0 is not first point, you just see. T equals to 0, if you are thinking initial velocity t equals to 0, t equals to 0 is not first point, so you cannot able to use the reduced formula. With the help of Newton forward interpolation, as like as there, you just see. Are you seeing this? Newton forward interpolation, you just do derivative here with respect to u outside 1 by h, and if x0 is 1.5 suppose, and x is asking point 0, 0 minus 1.5 by 1, like that for that example. So whatever the u, you will get that u value you have to use in this expression. When you will get u 0 means asking point is directly coincide along with the first point, then you will use this reduced formula, what is we have derived here. Okay, otherwise this formula you have to use. So for t equals to 0, you will use that basically starting interpolated technique. That polynomial you just do derivative and put t equals to 0. Okay. Now come to the question number 2. Question number 2, ds by dt at first point. First point and initial point, what is difference? That is, you just try to understand or nothing else. If t initial point is t equals to 0 is given to you, means t equals to 0 is not first point here. So that time that with the help of Newton forward interpolation, what is the polynomial you will get? That polynomial you just do derivative with respect to t. Means first with respect to u and u with respect to 2, that is 1 by h. You just multiply left hand side. And you will calculate step by step. Okay. And these are the upper diagonal elements. Okay. These values, and these values. Now, what is my logic? Actually, derivative at first point. First point is asking point is first point. It is coincide. Then I can able to use that nice reduced formula. What is we have? I told you to remember. Okay. So that time outside 1 by h. What is h for these data sets? 1 by 0.5. First difference, that is upper diagonal elements. First difference, second difference, third difference. Then remaining difference is 0. So these minus this by 2 plus this by 3. For the forward differences for upper diagonal elements, alternating series. This minus this by 2 plus this by 3. Just see this expression. First difference minus second difference by 2 plus third difference by 3. Outside 1 by h. That is 4.75 semi per second. That is CS1 group you have done in lab, I think. Is it clear? Students?
Yes.
Am I audible? Is it visible?
Yes, sir.
Screen is visible or not? Nicely. Now, can you able to calculate second derivative at 1.5? सेकंड डेरिवेटिव में क्या बोले थे तुम लोग याद करो, जैसे हम फॉर्मूला फिर नहीं देख रहे हैं, ऐसे हमको याद है. जैसे सेकंड डेरिवेटिव स्टार्टिंग फ्रॉम सेकंड डिफरेंस, मींस सेकंड डिफरेंस इज दिस माइनस सेकंड थर्ड डिफरेंस प्लस 11 by 12 fourth difference. So this minus this plus 11 by 4 into 0 outside 1 by h square. Okay. Second derivative at 1.5. 1 by h square. What is this value? 3 minus this. Second difference minus third difference plus 11 by 12 fourth difference. Fourth difference 0. So this minus this only. 3 minus this. That is 9 semi per second square. That is the acceleration at 1.5. Initial acceleration also you may think, or not, basically starting acceleration. Okay.
Yes, sir.
If it is asked to you calculate the derivative and acceleration at 2.0, then associate to these elements which will be the upper diagonal elements. That time upper diagonal elements will be this. Using these values, you have to use the same formula. Means you have to think now these are the upper diagonal. That is now del y0, del square y0, del q y0. Okay. So derivative, first derivative at this point means outside 1 by h. What is h here? That is you will multiply this term minus this term by 2 plus this term by 3. Outside 1 by h. Second derivative outside 1 by h square, this term minus this term. So derivative velocity and acceleration at 2.0 also you may be able to calculate. And that is already we have calculated here. Okay. And to calculate derivative at last point or second derivative for this example acceleration, at last point you have to pick up the lower diagonal elements. These are the grade yn, grade square yn, grade q yn, like that. Okay. That formula you have to rearrange. You have to use these two formula. Okay. So to calculate velocity and acceleration at last point, these diagonal elements you have to pick up, and to calculate velocity and acceleration at second last point, means at 3.5, these values you have to associate to these, which will be the lower diagonal elements. That values you have to pick up, and you have to rearrange the same formula what is you have derived. Is it clear, this question, how it will be solvable?
Yes, sir.
Okay. So I think for any data sets also, at least first derivative or second derivative, first derivative at first point or second point, or last point or second last point, it will be asked to you. Sometimes it will be asked to you second derivative. If second derivative will be asked to you, obviously you will not get more than 5 points. Okay. Because in second derivative, the formula is associate up to 4 difference. So obviously it will not give you more than 4 points. Because more than 4 points is, if it is given to you, means next term, if it is necessary to calculate, you have to remember a lot of the things. And for that purpose, if you will not remember, you have to derive a lot of the things. So that is lengthy process. So scientifically, who will create the question, maximum to calculate the second derivative, maximum only 5 points will be asked to you. And in that way, you will solve the questions for theory questions. Now ask me. If you do have any query, you may ask. Very less students. Any query?
Nothing, sir.
Okay, very good. So we are ending the meeting. Or you need this slide? Numerical integration, derivative.
Yes, sir.
Okay, I am uploading in file section. Okay, you will collect. Okay.
Okay, sir. Okay, sir.
Okay.
Thank
We
you,
are
sir.
ending the meeting. I am uploading soon. Okay.